So I'll ask you guys first, do you have any lingering questions? Anything that um, you remember from last time that you wanted to chat about or anything like that? Anybody? Okay. I think that is a no. I heard no voices. So um, let's go ahead and um, go back down to the problems where we were practicing. So I think um, last time, if I recall, we made it. Does anybody remember which question we made it to? Was it 13 or 14? Remember we were pretty far down. Nobody remembers the last question we did? Okay,
I,
well,
I think we did 15 last time.
yeah, I think that's what I thought too. And then I gave you guys one to work on, um, but we can go ahead and work on the next one. So I think I said yeah. So 16 would be interesting. So why don't you guys go ahead and work on 16, and then I'll chat with you guys in a couple minutes. Does anybody have any questions about that? No. Okay. Number 16. Okay. See you guys in a minute. Okay. So, Z, you there?
Yes, Professor.
Okay.
Um, mhm.
So what do you think?
Excellent. I'm still trying to work out on that. I'm trying to figure out when like the X1 first, and then I don't actually know what do they mean by X1 being the value of X associated with point of intersection. Do they mean by X1? I don't think they mean that X1 is the point of the intersection. So they mean by the X of the functions. So I'm trying to
No,
figure.
no, 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 no. Actually, so normally when you have like a designation like that, that's like, we have a point of intersection and we already found it, remember?
Yes.
So if so they're saying what's the x component of that point of intersection, and
Oh,
right, so we had before we're writing the ordered pairs like x and y.
oh, I
So they're
see.
just asking what's the x value. In our case, um, we know
17,
that,
right?
yeah, we know it's 17.
So
So
that'll be 20.
yeah, so x2 is 17
All right.
plus 5, which is just 22,
Oh, I see. I got it now. One
right?
more minute.
Right. So does everybody see what I did? Does anybody have any questions about that? So we're finding the x um, component, and we're using it to construct this other x2 value, which is going to be 17 plus 5. X2 is 22. And then it says, what's the difference between um, the undercurve areas of the two equations? Now that one's going to be a little bit tricky, and I just want to show you guys really quickly that there's only one good way to do this, and that is I've got one equation, which is the y is equal to 107 minus 4x, and 107, and this is the x2 value, which is 22. And so So there's my graph. Can you see this Z? There's 107, downward sloping, and there's the value 22.
I saw new points.
What's that?
Yes.
Right. So they're looking for the area of this trapezoid here for equation 1. And for equation 2, right, it's the same thing except for it's an upward sloping equation and it has our intercept of 5. And again, we're looking at x at 22. And we're looking like that. Does that make sense, Steve? Does that?
Oh, I see.
Right.
Yeah.
So we've got these two areas, and they want to know the difference between them. And it could be a positive or a negative number, right? It's like, you know, if you had the square footage, which is the area of a house, right? And you'd say, well, I got 2 houses. One has a square footage of 2,100 square feet and the other one has a square footage of 1,600. What's the difference between them? Well, it's 500 square feet. It's 2,100 minus 1,600 is 500. That's the difference between them. Could be that you take the smaller house first and you have 1,600 minus 2,100 and you get a negative 500 square feet. So that's a good problem. Now, notice you guys have already, like, through working through the assignment, you've already solved all of these types of problems doing the area under the curve. The only difference is that now you're subtracting one area from another, which you haven't done before. Okay. Do you have any questions about that, Z?
I got it now. Thank you.
Okay. And Stephen, you there?
Yeah.
Okay. So were you able to work this one out? Do you?
I came up with one answer. I don't know if it's correct or not.
Okay. Can you tell us what you did?
Oh, first I got the 2 equations and it set for a y value of 2. So I put, for both equations, I've set 2 for y.
Right.
And then I solved for x. And then I minus each of them to find the difference.
Yeah. And so distance is interesting because it's not the difference, it's the distance. And distance is always a positive number, right?
Yeah.
So it shouldn't matter. At least I think this will always be positive because they're saying distance. Normally distance is positive. So I don't think they mean one minus the other. But what you meaning that you could get a negative answer. I don't think that's the case. They're always looking at distance. But you should have had, and so this one is a little bit different because it's different than the other equations because it's 2 plus 5x, but it's still an upward sloping line. And in this case, Stephen, we should have a graph that looks like this. So there's the downward sloping line, there's the upward sloping line, and this is where y is equal to 2. And one of them, right?
Yeah.
Y is equal to 2 for, oh, actually, I take it back because, yeah, no, that's right. So y is equal to 2 because this is at the intercept for the upward sloping equation is satisfied at x value of 0. And then this one, y is equal to 2. So I would set 107 minus 4x equal to 2. and I'd get 105 minus 4x, or 105 is equal to 4x. So 105 divided by 4, right?
I got 26.25.
Yeah. So 26.25.
Yeah.
And yeah, that sounds right to me. So big reveal. Yeah. So that distance is 0 to 26.25. That dashed line there. So Z, do you want to tell us, did you calculate the two areas and take the difference?
Yeah.
What'd you
I'm
get?
still doing that. I'm sorry. I'm kind
Okay.
of lost in a way.
Okay, what are you lost about?
Because the two graphs you showed me, like yes, from question number 16, I think I start to get lost at there, because at that one I actually find a triangle. So after that, I'm trying to figure out the rest.
Yeah, so this obviously isn't a triangle. This is a trapezoid, right?
Yes. Yeah.
And so you have to find the area of a trapezoid. And remember, we gave you the formula for area of a trapezoid last time.
Mhm.
It's base 1 plus base 2 divided by 2 times the altitude or the height of the trapezoid, which is the distance between the two bases. Well, in this case, right, we have the height, or the altitude, is given as 22. The only thing we're missing is we don't know the length of this base here, right? This one we know is 0 to 107 along the vertical axis, so that's 107. This one, what we have to do, right, is we have to plug x is equal to 22 into our equation to find out the y value that's associated with that point. See what I mean?
I think so. That'll be 19.
Okay, well, I mean, if you plug it in the equation, let's see. 4 times 22 is 88, and 107 minus 88, yeah, 19. I agree. And now the other one, it's the same idea, but now you have to do 22 into the equation 5 plus 2x, because we said the x is missing there in the rendering of it, but it's supposed to be an x. So what did you get?
I think I got
40.
49.
Yeah, 49. 49. So 49. So now you have, like, for example, in this one, you have base 1 is 5, base 2 is 49, and the height is 22. So it's 5 plus 49, which is 54, right? Divided by 2, which is 27 times 22, right? Do you agree?
Yes.
Okay, so what's the answer for this area?
For the first one,
Well, this
for
is the bottom one, but
all
anyway.
right. So for the bottom one, I think I got like 1,741.5.
Well, so check your calculator and tell us.
Yeah. Yeah, that will be 27.
You can just write it in the chat for us, the formulas for each of them.
Oh, I got 364.
Okay. So just because you sound shaky, I'm going to check on my calculator too.
Okay.
Okay. So, so we said it was 54 divided by 2 times 22. And I got 594.
Hmm.
Well, I mean, 27 times 22, 594. Do you disagree with something? I got 5 plus 49 divided by 2 times 22, and that's equal to 27 times 22, which is 594. So, do you have a... That's for the bottom one. Do we agree?
Yeah.
Well, I'm just saying, because you sound like you're very hesitant, so I don't want you to just agree with me because I'm the professor. So you agree with me. I mean, hopefully you understand and you agree because you agree with the calculation. Is there some issue?
Um. No, it just because I think I totally missed step on number 16. So I got totally different answers, and because they're all like connected between these three, so I think I start to get lost.
Yeah, well. So they are connected, but remember that 16 was just different. 16 was, so stop thinking about 16. Just concentrate on the one we're working on. But 16, we were looking for the area of this triangle,
Mm-hmm. Yes.
right? And now we're looking for the difference between these two lines at a point past the point of intersection, right? The point of intersection we said was 17. Now we're looking at 22. And the thing is, the reason why I separated the two graphs for the area under is that these two areas overlap. And so there's no good way of illustrating areas that overlap when you take the difference. So, you can forget about this picture and then just separate the two graphs and look at the areas for each of them individually and then take the difference. Do you see what I mean?
Yes.
Okay. So we said the bottom graph had an area of 594. What about the top graph? So what do you think?
Um.
Well, it's the formula for the area of a trapezoid. Which
Yes.
remember, that's B1 plus B2. What's our one base?
Well, I think our B1 plus B2 will be 22 plus 27, right?
Well, for this one, I see a base here of 107.
Oh, all right.
And I see
Yeah,
a base
I think
here of 19.
I just missed the base and height.
Yeah, so it should be 107 plus 19 divided by 2. You can do the calculator for us on that one. So,
So now I got
and then multiply it by the height or the altitude, which is 22. So what
I
do you get?
got 2,193.5 on that one.
Okay, so I'll double check. And let's see if I agree with you. Okay. So we got 107 plus 19 equals 126 divided by 2. It's 63 times 22, and I got 1386. Yeah, but what
Yes, I
calculation?
think I did the same thing. I took 22. No, I took 19 plus 107
Yeah. Okay, divided by 2.
divided by 2 times.
Because remember, and I'll write it one more time. Just let's let me find a good place to do it. B1 plus B2 divided by 2.
2,326.
Okay. Do you see? B1 plus B2 divided by 2. So 19 plus 107 is 126, right?
Mm-hmm.
Divided by 2
I typed.
is 63, right?
Yeah, I think
And-
you're right. Type on calculator. So
And then
1,000.
yeah, 1386, right? And then 63 times 22 is 1386, right?
Yes.
Okay, so let's look at our final. So we should say the difference between the two areas under the curve. So our first area is 1386, and our next one is 594. What's 1386 minus 594?
792.
Okay, let's see. Okay, let's see. 1386 minus 594. Yeah, I got 792 also. I wonder if we made a mistake someplace. That's not very satisfying after we went through all that work. Well, I'll tell you what. I'm sure of our technique. I don't know. I don't think it's an error on Ignithium. There are a few, but they're pretty rare. So I'll leave it at that, and I'll let you guys figure it out. Because if you guys, and I should say now that we're going to assign this for our homework, and we'll have it due next Tuesday for you guys to turn in to online on Blackboard. We'll have a box available for you guys. You guys will see it. It's like a turnitin.com or Turnitin assignment.